Manually configuring network components leads to configuration drift and security gaps. Terraform defines your infrastructure as code to ensure every environment is an exact replica of your validated architecture. The virtual private cloud resource establishes a logically isolated section of the cloud. You must define a primary classless interdomain routing block to determine the private address space available for all resources. Choose a 16-bit mask for 65,536 addresses. Avoid overlapping ranges with your existing on-premises data centers to prevent routing conflicts during future network peering or hybrid connections. Set Enable Domain Name System hostnames and support to true within the resource block. This ensures that instances launched in the virtual private cloud receive a public domain name system name corresponding to their public Internet Protocol address. An Internet Gateway is a horizontally scaled and redundant component that allows communication between your virtual private cloud and the Internet. It provides a target in your route tables for any traffic destined for external addresses. A subnet is considered public if its traffic is routed to an Internet gateway. Use the classless interdomain routing subnet function in Terraform to programmatically divide your primary block into smaller segments across different zones. Private subnets have no direct route to the Internet gateway. This isolation is mandatory for database tiers and backend application logic that must remain unreachable from external probes or direct attacks. Define a custom route table for your public subnets rather than relying on the default main route table. This provides granular control and prevents accidental exposure of private resources if the default configuration changes.
Add a route entry with the destination 0.0.0.0/0, pointing to the Internet Gateway identifier. This represents all traffic not destined for the local network. Explicitly link your public subnets to the public route table using the Route Table Association resource. Without this explicit link, the subnet will fall back to the main route table, which often lacks Internet access. Instances in private subnets require a Network Address Translation Gateway to download patches or access external application programming interfaces. It translates private source addresses to a single public address for outbound requests. A Network Address Translation Gateway requires a static Elastic Internet Protocol address. Declare an AWS EIP resource with the domain attribute set to Virtual Private Cloud to ensure the address is persistent across gateway restarts. Place the Network Address Translation Gateway within a public subnet. It must reside in a subnet that has a route to the Internet Gateway to successfully forward traffic from your internal resources to the web. Create a separate route table for private subnets. Instead of an Internet Gateway, use the Network Address Translation Gateway identifier as the target for the 0.0.0.0/0 route. Associate each private subnet with the private route table. This ensures that any data leaving these subnets must pass through the Network Address Translation Gateway, which prevents unsolicited inbound connections from the Internet. Distribute your subnets across at least 2 availability zones. This ensures that a single data center outage does not take down your entire application by providing redundant paths for traffic and failover capacity. Use the data source for Amazon Web Services availability zones to fetch names dynamically. This prevents hard coding zone names, which can vary between different cloud accounts and regions.
Employ the count or for each meta argument to generate subnets based on the number of available zones. This makes your Terraform code scalable and adaptable to different regional capabilities without manual editing. For public subnets, set the Map Public Internet Protocol on Launch attribute to true. Any instance deployed here will automatically receive a public address, which is necessary for reaching the instance via Secure Shell. Security groups act as a virtual firewall for your instances. Because they are stateful, allowing inbound traffic automatically allows the corresponding outbound response traffic, regardless of egress rules. Explicitly define egress rules to limit where your instances can send data. Restricting outbound traffic to specific ports or destinations reduces the risk of data exfiltration if an instance is compromised. Network access control lists provide an additional layer of security at the subnet level. Unlike security groups, they are stateful, which means you must explicitly define both inbound and outbound rules for communication. When using network access control lists, you must allow inbound traffic on ephemeral ports, 10,240 to 65,535, to receive responses from Internet servers. Store your Terraform state file in an Amazon Simple Storage Service bucket. This enables team collaboration and ensures that the source of truth for your infrastructure is not tied to a single local machine. Enable state locking using a Dynamo database table. This prevents two users from running Terraform apply simultaneously, which could lead to state corruption and inconsistent infrastructure resources. Use the required providers POC to constrain the Amazon Web Services provider version. This prevents breaking changes in newer provider releases from impacting your stable infrastructure deployments.
Implement validation blocks within your variables to enforce naming conventions or specific range limits. This catches configuration errors early before any resources are actually provisioned in the cloud environment. Define output values for the virtual private cloud identifier and subnet lists. These values are essential for other Terraform modules or external systems that need to deploy resources into the network you just created. Terraform workspaces allow you to manage multiple environments, like development and production, using the same configuration code. Each workspace maintains its own separate state file to prevent environment cross-contamination. Use local values to store repeated expressions or tagging logic. This follows the do not repeat yourself principle, making your code easier to maintain and reducing the likelihood of manual typing errors. Enable virtual private cloud flow logs to capture information about the Internet Protocol traffic reaching your network interfaces. These logs are vital for security audits and troubleshooting connectivity issues. Direct your flow logs to either a CloudWatch log group for real-time analysis or an S3 bucket for long-term storage and cost-effective analysis using Amazon Athena. Provision a virtual private cloud endpoint for simple storage service to allow private subnets to communicate with S3 without a network address translation gateway. This reduces data transfer costs and improves performance. Use interface endpoints powered by Private Link for other services like Systems Manager or Elastic Container Registry. These appear as local network interfaces with private Internet Protocol addresses inside your subnets. Define a dynamic host configuration protocol option set if you need to provide custom domain name servers or NetBIOS settings to your instances. This is common when integrating with Active Directory environments.
Always review the output of Terraform plan before applying changes. The plan shows exactly which resources will be created, updated, or destroyed, ensuring no unexpected modifications occur to your production network. While Terraform handles most dependencies automatically, use the depends on meta argument for cases where timing is critical. For example, ensure an Internet gateway is fully active before creating a network address translation gateway. Apply the lifecycle prevent destroy meta argument to foundational resources, like the virtual private cloud. This adds a safety layer that prevents accidental deletion through the command line or automation scripts. A peering connection enables you to route traffic between two virtual private clouds using private addresses. Traffic remains on the Amazon global network and never traverses the public internet. When managing dozens of virtual private clouds, use a transit gateway as a central hub. This simplifies network topology by replacing complex point-to-point peering with a star-based architecture. The identity and access management user or role executing Terraform must have the specific permissions required to manage network resources. Avoid using the full administrator access policy to adhere to the principle of least privilege. Network address translation gateways incur hourly charges, plus data processing fees. Consider using a single gateway for multiple subnets in development, but use one per availability zone in production for fault tolerance. Terraform Refresh updates your local state file with the actual current configuration in the cloud. This detects drift caused by manual changes in the web console and allows you to revert them to the coded standard. Use the target flag with the destroy command to remove specific resources without affecting the rest of your network. This is useful for testing individual components, like a specific security group rule or subnet.
Successful virtual private cloud deployment relies on the cycle of plan, apply, and version control. This methodology transforms networking from a brittle manual task into a reliable and scalable software delivery process.